Dear students, welcome to our science episodes. Today we are going to continue discussing energy resources and forms. Energy resources and forms. In the last episode, we discussed potential energy. Today we are going to discuss kinetic energy. You remember when the bowstring was drawn backward, then potential energy was stored in the arrow and the strings, of course. When the arrow is left, the stored potential energy converts to kinetic energy while the arrow is moving. So kinetic energy is work done during the motion of an object. What is meant by kinetic energy of an object is equal to 50 joules? This means that work done during the motion of the object is equal to 50 joules. What are the factors affecting kinetic energy? Mass. Remember, in potential energy it was weight. Here it is the mass. If we have two cars, one has more mass than the other. Of course, the truck is heavier than this small car, and they are moving at the same speed. Which one needs more work to stop? The heavier one. Factor number 2, speed. Look at this example. If we have two cars with identical mass and one of them is faster than the other, which one needs more work to stop? The faster. So this means that kinetic energy of moving objects increase by the increase of the mass or the speed of the object. Now we can calculate kinetic energy by half multiplied by the mass multiplied by square of the speed of the object. What is meant by kinetic energy of an object is equal to 0. This means that the object is at rest. Its speed is 0. Calculate the kinetic energy of an object. Its mass is 8 kilograms and its speed is 2 meters per second. Kinetic energy equal half times mass times square of the speed, which is equal to half times 8 kilograms, which is the mass, and 2 times 2, this is the square of the speed, it will give me 16 joules. Calculate the mass of an object. Its kinetic energy is 48 joules and its speed is 4 meters per second. Kinetic energy is calculated by this equation. This means that the mass equal kinetic energy times 2. This will be here as times 2 and divided by the square of the speed. Therefore, equal 48 times 2 divided by 4 times 4, which is equal 8. This will give me 6 kilograms. Now, let's discuss together mechanical energy. If you try to raise a tennis ball up to your head level and then leave the ball to fall down to the ground, what is your observation? What will happen to the tennis ball? The ball will hit the ground and keep bouncing off the ground. You know the motion of the basketball or the tennis ball? When you try to hit the ground by these balls, they keep bouncing off the ground, up and down, up and down. The conclusion is, when the ball is lifted up high, it stores potential energy. When it is left to fall down, potential energy is converted to kinetic energy. When it hits the ground, some of the kinetic energy convert to potential energy, and so on. from potential to kinetic and from kinetic to potential. Therefore, mechanical energy is the sum of potential and kinetic energy of an object. So what is meant by mechanical energy of an object is equal to 100 joules. This means that the sum of potential and kinetic energy of this object is equal to 100 joules. Can you calculate the mechanical energy of an object if its potential energy is 1000 joules and its kinetic energy is 230 joules? You have the potential energy and you have the kinetic energy. Can you calculate the mechanical energy? We said it is the sum of both kinds of energy. So 1000 plus 230 equal 1230 joules. Look at this picture. This is a cannon throwing a ball upward until it reaches the maximum height, and then it will fall down to the ground. So at point C, it's the maximum potential energy of an object. Kinetic energy at this level is 0, and the mechanical energy is equal to the potential energy. At point D, this is half the way between the maximum height and the ground. The potential energy is equal to kinetic energy, equal half of the mechanical energy. Here, mechanical energy equal 2 times potential energy, and at the same time equal 2 times its kinetic energy. At point E is the point just before the ball hitting the ground. It has 0 potential energy, maximum kinetic energy, and mechanical energy equal the kinetic energy of the object. Mechanical energy and mechanical energy equal to the kinetic energy of the object. From this picture, we conclude that mechanical energy of the object equal its potential energy at the maximum height, which is point C, which is equal to the kinetic energy just before hitting the ground at point E. Give reason why the mechanical energy of a falling object does not change with the decrease of its potential energy. This is because the potential energy is converted to kinetic energy while falling down. Look at this problem. An object with mass equals to 5 kilograms falls down from 8 meters height. Can you calculate its potential and kinetic energy at maximum height, half the distance between maximum height and the ground, 2 meters height, and just before hitting the ground? At maximum height, the kinetic energy, of course, equals 0. The potential energy equal weight times height. And as we said before, weight can be calculated as mass times acceleration of gravity. If we will calculate this, we will get 5, which is the mass, times 10, acceleration of gravity, times 8, which is the height, equal 400 joules. At half the distance, which is 4 meters, potential energy equal to 5 times 10 times 4, equal to 100 joules. The kinetic energy is equal to the potential energy, which is equal to 200 joules. At distance 2 meters, potential energy equal weight times height. 5 times 10 times 2 equal 100 joules. Mechanical energy equal potential energy at maximum height, which is equal to 400 joules. Then we can get kinetic energy, which is mechanical energy minus potential energy equal to 400 minus 10 minus 100 equal, which is equal to 400 minus 100 equal 300 joules. Just before hitting the ground, potential energy equal 0. And kinetic energy equal mechanical energy equal to 400 joules. What do you notice from this problem? Can you notice from this problem that at the maximum height, potential energy is equal to mechanical energy, which is equal to 400 joules. Just before hitting the ground, mechanical energy is equal to kinetic energy, which is equal to 400 joules. This means mechanical energy stays the same whenever or wherever potential or kinetic energy change. Time for questions. Now choose the right answer. An object, its mass is 2 kilograms, is moving with a speed 4 meters per second. Its kinetic energy is equal to, you have here the speed and you have the mass. It is 16 joules. The potential energy of a falling object is equal to 0 when it is at its maximum height, it reaches the ground, its mass increases, or its speed increases. When it reaches the ground. At the maximum height of a falling object, what energy is equal to 0? Kinetic. Mechanical energy is equal to the sum of potential and kinetic energy. Calculate the kinetic energy of an object if its mechanical energy is 700 joules and its potential energy is 200 joules. Mechanical energy equal potential energy plus kinetic energy. And of course, kinetic energy equal mechanical energy minus potential energy, which is equal to 700 minus 200 equal 500 joules. Dear students, thank you for watching. See you later in other science episodes.